18 is a great calculus understanding problem. I'm talking about velocity and position graphs. Sarah left her math class and walked down the hall, where she stopped for a few seconds to talk to a friend. She realized that she had forgotten her calculator and walked back to class. After picking up her calculator, she realized she was running late and ran back to class. Sketch two graphs that illustrate Sarah's distance and velocity from her math class as a function. So I think we're kind of leading to this one being position. Or distance, and then this one being velocity. I say that because this one allows us to go in the negative direction, and we can have some negative velocity. We could have negative distance, but it would imply that we went back beyond where we started from, and that doesn't apply in this situation. So it really doesn't matter where you start first. I would encourage you in these problems to alternate, just so you can really solidify your understanding. So I'm going to start with the velocity. Sarah left her math class and walked down the hall to where she stopped for a few seconds to talk to a friend. So she left her math class and she walked. So we can assume that when she starts walking, she starts at her walking pace. You don't have to accelerate to walk. And then she stops for a few seconds. And we need to say that she stops by putting that down here. She's actually going 0. And then she realized, so she can decelerate to stop. Then she realized she had forgotten her calculator and walked back to class. Now, we got this negative walking here. And I would strongly encourage you to make sure that this and this were equal, because this implies where she went and stopped to her friend and she's going back. The areas of these need to match. After picking up her calculator, so let's say that, she probably has to stop in that room for a second or whatever. She realized she was running late and ran back to class. So her velocity here needs to be higher in the positive direction. And then she gets to class. I think that's a good velocity graph. Let's see how that relates to our distance graph. So a constant velocity has a constantly increasing distance. So it's got this low slope, she's walking. And then when she stops, her distance does not increase. It doesn't go to 0, but it just stops. And then she walks back to class. So I would say those slopes should be very similar, just opposites. And then she gets back to her class. So she actually does reach back to 0, but she's not going to go negative. And then she runs back to her next class. And she probably gets there right about here. This slope here is steeper than her walking slope because she was running. This slope should be equal to this y value right here. This slope should be equal to this y value. And then this slope should be equal to this y value. I think we've done a good job. We represented our stopping. Again, I would think this is a very important calculus problem to have mastered in pre-calculus.